morning, ladies and gentlemen. May I kindly request everyone to please stand for the Philippine National Anthem to be followed by the morning prayer.
Bayang magiliw, pero sa silanganan, alam ng puso, sa dibdib mo'y buhay. Lupang hinirang, duyan ka ng magiliw, sa manlulubi, di ka masisingil, sa lalat at bundok, sa simoy at sa langit mo kamay, nagilang ang tula at awit sa paglayang tinamay, ang kisap ng watawat mo'y nagumpay na nagiging, ang bituin ng araw niya kailan ang ay pagdidilim, lupa ng araw na maraming pagsita, ay langit sa likod, aming ligaya dapat may mamagin, at namatay lang tayo sa'yo.
And we are live. Good morning, magandang umaga, maayong buntag, Luzon, Visayas, and Mindanao, all over the Philippines. Good morning to all of you guys. I hope you had a very good sleep last night and are all doing fine this morning. Ayan. And also, I would like to greet our friends that are joining us outside of the Philippines. Good morning, good afternoon, and good evening to all of you guys, wherever you are. I just learned that we have participants joining us all the way from Singapore, from Taiwan, and other countries in Asia Pacific. Welcome, guys, and yes, welcome to CropLife Philippines webinar on mode of action labeling and herbicide resistance. This is actually the session 2. And by the way, before everything else, I would like to introduce myself. If you were here when we had our first session, you probably have remembered me. I am Jerwin Isarza, and I am with Aldis Incorporated. And as I always say, I do a little bit of regulatory and a little bit of stewardship on the side. But today, I am going to be your host. And thank you for joining us. And as said earlier, this is the session 2 of the series of webinars that CropLife Philippines is presenting. For those who didn't know, we had our session 1, which we talked about insecticide resistance back in July 14, 2020. Exactly 1 month ago today, which was very, very successful, by the way. That was the first time that we did it, and I think we think that it went well. We had about 180 participants then. And probably some of you guys who attended our first session are also attending to right now, right? And we appreciate it very much. And also, as our attendance is climbing up, right now we are about 160 in attendance. Very good attendance. And at this very moment, Before we officially open the program, please allow me to recognize our dear attendees and participants for this 3-hour session. And first, I would like to recognize the presence of the Fertilizer and Pesticide Authority, FPA, headed by the very active Executive Director, Wilfredo C. Roldan, on cam right now. Hi, sir. And of course, the Chief of Pesticide Regulatory Services Division, Ms. Jackie Romualdez. Ma'am, sir, thank you for joining us here and bringing along with you your whole team nationwide. Yes, we have the whole team of the FPA today, the FPA regional officers. Thank you guys for joining us and welcome to our online session. Also, I would like to recognize the presence of the National Crop Protection Center of the Philippines, NCPC, headed by the Executive Director, Dr. Gil Magsino. Dr. Hill, thank you, and thank you for tagging along your team in this session. By the way, later, Dr. Gil Magsino will be presenting in the session, so we all have to wait for that. All right, and also, I would like to recognize our dear participants from the International Rice Research Institute, IRI. Hello, guys. Thank you for joining. And also we have the presence of our friends from the academic sector. Wow, we have from University of the Philippines, Los Baños. We have from University of Southeastern Philippines in Mindanao. We have from Compostela Valley State College. That's also from Mindanao. We also have representatives from Visayas State University. Wow. Thank you, guys. Thank you. It's nice to see our doctors, our researchers, and our scientists joining us today. And who else? We also have representatives from the Bureau of Plant Industry, BPI. Hello, hello, welcome. We also have attendees from the Agricultural Training Institute, ATI. Welcome, guys. From the Department of Agriculture and some DALGUs, our local government units. And also we have attendees from FieldRise. Nice. Thank you, guys. We also would like to recognize the presence of some dealers and distributors. Wow, it's nice to see you here. And at the very least, all the stakeholders are represented in our session today, right? We even have people from Bounty Fresh, is that right? Bounty Fresh, I think it's the chicken company, right? So welcome. And also our friends from the Crop Protection Association of the Philippines, the CPAP team, headed by the Executive Director, Mr. Didi Gonzalez. Wow, thank you guys for joining and welcome to CropLife webinar session. And also, I would like to greet our friends from CropLife Asia and CropLife Taiwan. Thank you for tuning in. I won't be able to mention you one by one, but you know, guys, who you are. We appreciate the support and welcome. Special mention to Miss Susan Knight of CropLife Asia, Chair of FRAC Team, Asia Pacific. Also, special mention to Dr. Luis Camacho, the HRAC for Asia Pacific. Good morning, sir, ma'am. And also, I'd like to mention the presence of our CropLife Regional Action Network teams all over the Philippines. Welcome, guys, our CRAN team. Thank you for tuning in. And also, I'd like to recognize, of course, the representatives or the CropLife member, the CropLife Philippine members. We have from Aldi's Incorporated, we have from BASF Philippines, Bayer Crop Science, Biosid Philippines, CB Agro Asia, Corteva Agriscience, FMC Agro Philippines, Jardine Distribution, SC Johnson Philippines. We also have from Sinochem Crop Protection Philippines, Syngenta Philippines, and UPL Philippines. I hope I mentioned all of the members. And let me know if I missed out someone, all right? So, there. And if there are other institutions or organizations out there that I was not able to mention, please let me know. We would love to mention you here. And we would like to recognize you as well. So there, who else? I think that was it. Thank you so much for for tuning in. We are about 180 in attendance right now. We actually did not expect this so much of attendees, but we are glad that we were able to reach out to all of you no matter where you are right now. As the world is shifting to the digital normal, right? Or the new normal, as everyone is saying, due to this global pandemic. So yeah, thank you for connecting with us today. And right now, I think it's the time for me to stop talking. Let's officially open the program, shall we? To give our opening remarks, I would like to call on the president of CropLife Philippines and the country head of FMC Agro Philippines, ladies and gentlemen, Ms. Veronica Tiburcio. Ma'am Veronica, you have the mic.
Yep. Can you hear me all? Thank you. Thank
Yeah,
you,
sure.
Jerwin. So, good morning, magandang ani, everyone. So, I know that this is the new normal that we have right now. And I really pray that all of us are safe, including our family and, of course, all our stakeholders, employees as well. So, I'd like to recognize the effort of CropLife in this webinar. Of course, Jerwin already mentioned a lot of stakeholders joining us today. So again, thank you so much. CropLife Philippines is really committed to make sure that not only us, not only CropLife are informed and trained, but we are extending this webinar to all our possible stakeholders, as also mentioned during the last webinar that we had. I think FPA also encouraged us to extend this invites to other stakeholders. So we are really happy that we were able to help you in this time. And of course, I'd like to request everyone to participate and ask questions. We have experts here in the call. They can answer your question. If not, we can come back to you and give some answers to your question. So without further ado, I'd like to thank you all again and stay safe and be healthy. Thank you, Rin.
All right, thank you very much, Ma'am Veronica, for that very, very short opening remarks. That was wonderful. And also to add, I would like to, I have read a lot of chat here. I'd like to greet from DMMSU NLUC. I think this is a school. Also from CLSU, good morning to all of you. From MSU Malawi, from Dole Philippines, thank you for joining us here. And who else? From Central Philippine Adventist College. Wow, thank you guys. There, so what's this? Prime Stocks Chemical Corp. All right. Thank you very much for joining us, and just keep the chat going. So again, that was Ma'am Veronica, the president of CropLife Philippines, and right now, let's move forward. We also would love to hear a message from this very important individual. We requested a short message from him today. I am referring to the Executive Director of Fertilizer and Pesticide Authority, Director Wilfredo C. Well done. So really, you're there?
Good morning to everyone. To the management and members of CropLife Philippines, to the resource persons today, experts from the government, from the industry, and from the academe, to all those farmers listening now all over the country, to our regional officers, and fellow workers in government, to our distinguished participants, a pleasant good morning to everyone. First of all, I would like to thank CropLife Philippines for giving me the opportunity to grace this occasion. And it is indeed our greatest honor and pleasure. As you know, the Fertilizer and Pesticide Authority is proud and always be proud to have CropLife Asia with us, collaborating in helping the industry perform better in the country. This is an organization that is committed to promote and advocate new approaches that enhance sustainable agriculture in the interest of the farmers, for the government, for the consumer, and to the environment as well. I congratulate CropLife for conducting this second seminar with the theme MoA labeling, herbicide and resistance management. You know, this is a very important activity for the industry. In order to strengthen and enhance our knowledge, particularly among the participants, and understand the mode of action, labeling, and herbicide resistance management to help in facing various issues and concerns across the country, and to be able to share this knowledge and best practices in the agriculture. It aims to promote and enhance knowledge about the mode of action labeling. We want to see more clear understanding and better basic principles and herbicide resistance management, and have a concrete procedures on how to manage herbicides resistance, particularly in key crops, rice and corn. As we participate in this seminar, I encourage everyone to share your experiences, take note of key success factors from our resource persons. Rest assured that EPA is committed and will always commit to a long-term and vibrant partnership with CropLife and all pesticide associations in the country for a better herbicide application and a better environment. Again, I would like to reiterate my sincere appreciation to the organizer, particularly CropLife Philippines, with the hope that this seminar will bring about new insights in our daily works, in giving a better opportunity for the farmers to have a better life. A fruitful day to everyone. Mabuhay tayong lahat. Good morning.
All right, thank you, Director Roldan, for that very, very encouraging message. Thank you, and mabuhay tayong lahat indeed. And thank you for that very enlightening and very nationalistic approach to our, especially in our industry. And yes, this webinar is very timely since the FPA just published their updated policies, their updated rules and regulations. Of course, I am talking about the new FPA Green Book. As a pesticide company, we are now required by the FPA to include the mode of action of the active ingredient, right? Or the combination of active ingredients in the label. So, and as Director Roldan said, this is the time that we have clear understanding about this. Right, so right now, we will take a short break talking, but instead we will be presenting an audio video on herbicide resistance. I know some of you guys are already familiar with what is herbicide resistance, but for the benefit of those who are just learning this topic now, this video will give you a good head start in understanding what is herbicide resistance in general.
Parami ba ng parami ang mga tumutubong damo sa inyong sakahan? Umaabot na ba ito sa punto na tila hindi na namamatay ang mga damo kahit ilang beses isprayan ng herbicide? Baka herbicide resistance na yan. Ano-ano nga bang dahilan at bakit dumadami ang mga damong hindi na kayang patayin ng mga nakasanayan na laging ginagamit at dating mabisang herbicide laban sa katulad ding damo? At mas importanteng tanong, kaya pa ba itong mapigilan at masolusyonan? Hayaan ninyong ituro namin ang mga paraan kung paano maiiwasan at masusolusyonan ang ganitong problema sa mga sakahan. Sa pamamagitan ng Herbicide Resistance Management. Ano nga bang herbicide resistance at paano ito nag-uumpisa? Ang herbicide resistance ay ang naipapamanang kakayahan ng damo na mabuhay at hindi tabla ng isang uri ng herbicide na kaya namang pumatay ng ibang kauring damo. Dumadami ang damo may sadyang angking tibay laban sa uri na magkakatulad na herbicide base na rin sa paggamit na magsasaka dito. Habang patuloy ang paulit-ulit na paggamit ng iisang herbicide sa sakahan, dumadami ang mga damong hindi na tinatabla na tumuunti ang bilang ng mga damong kayang puksain ito. Bakit kaya nagkakaganito? Silipin natin kung ano ba nangyari sa isang sakahan. Sa isang sakahan, normal na tumutubo ang mga damo na may iba't ibang biotypes o mga katangian na may kinalaman sa pagtubo at pagdami ng mga ito. May dalawang uri ng biotypes. Ang una ay ang damo na resistant. Ito yung mga damong hindi namamatay kahit may sprayan ng herbicide. Mayroon ding mga seeds na galing sa katulad na matitibay o di tinatablang damo na matagal nang nakadeposito sa lupa dahil sadyang naipon na. Ngayon, kung patuloy na ginagamit ang produktong di epektibo, mas patuloy na dadami ang mga seeds ng damong matibay. Paalala, namamana ang resistance o ang kakayahan ng damo na hindi tabla ng herbicide. Ang isa pang uri ng biotypes ay ang susceptible o iyong tinatablan. Ito naman yung mga damong madaling mamatay kapag nalagyan ng kaparehas na herbicide. Sa pangkalahatan, marami at iba-iba pa rin ang uri ng mga damo. Kaya naman ginawa ang labeled rates para masigurong epektibo ang pagpatay sa mas maraming uri ng damo. Sa labeled rates, makikita ang tamang active ingredient pati na rin ang wastong dami ng herbicide na gagamitin sa kada ektarya ng sakahan. Dagdag pa rito, siguraduhin gawin ang pag-spray ayon sa rekomendadong timing, ibig sabihin, dapat sundin ang labeled rates dahil ito ang inirerekomenda ng mga eksperto. Kapag sobra kasi ang ginamit, maaaring masira ang mga pananim at karagdagang gastos lang ito. Kung kaunti at laging kulang naman ang dosage, hindi makakayang patayin ng herbicide ang damo at mas maraming makakalusot na damong kakayanin ng underdose. Suriin natin kung paano nag-uumpisa at dumadami ang mga damong herbicide resistant sa mga sakahan. Halimbawa, makikita natin na sa unang paggamit, mangilan-ngilan lang ang resistant na damo sa sakahan habang marami ang susceptible. Ipagpalagay natin na hindi sinunod ng magsasaka ang nakasulat na labeled rates dahil hindi pa nila alam ang konsepto ng herbicide resistance. Matapos may sprayan ng herbicide, namatay ang mga susceptible na damo o yung mga tinatablan, habang ang resistant na damo o hindi tinatablan ay nabuhay. Lumaki ang resistant na damo at naglabas ng seeds sa lupa. Sa mga unang pagkakataon, successful ang pagkontrol sa damo. Sa kalaunan, kapansin-pansin na mas dumadami ang bilang ng mga resistant na damo. Sa mga susunod pang paggamit ng parehas na produkto, mapupuno na ng mga seeds na resistant ang lupa. At sa pagkakataong ito, bigo na ang magsasaka sa pagpatay ng mga damo sa kanyang sakahan. Ano-ano nga ba ang mga bagay-bagay na nakakaapekto sa bilis ng pagdami ng mga resistant na damo? Paggamit ng iisang uri ng mode of action herbicide ng tuloy-tuloy. Hindi pagsunod sa nakasulat sa label. Dalas ng paggamit ng herbicidyo. Mechanism of action ng herbicidyo. At biology o katangian ng damo. Paano naman malalaman ang level ng herbicide resistance? Ang tindi ng weed resistance ay nakabase sa weed biology at mekanismo. Sa ilang mga kaso, ang tunay na resistance ay nakikita kapag mayroong mga damong nabubuhay matapos ang aplikasyon ng labeled rate at wastong timing batay sa good agricultural practice. May mga pagkakataon pa nga na ang mga damo ay maaaring mabuhay kahit gaano kataas ang aplikasyon kumpara sa labeled rate. May tatlong uri ng herbicide resistance. Ang single herbicide resistance kung saan ang damo ay resistant lamang sa iisang herbicide. Ang cross herbicide resistance kung saan ang damo ay resistant sa dalawa o mahigit pang uri ng herbicide na may parehong mode of action o paraan ng pagpatay. At ang multiple herbicide resistance kung saan ang damo ay resistant sa dalawa o higit pang herbicide na magkaiba ang mode of action. Base sa pag-aaral, ang mga pinakamahusay na paraan para maiwasan ang herbicide resistance sa mga damo ay itinatag sa konsepto ng diversity o pagkakaiba-iba. Ang diversity ay maaaring makamit sa paggamit ng iba't ibang kombinasyon ng mga paraang nagpapababa ng selection pressure ng isang nakasanayang paraan. Ang herbicide resistance management ay pwedeng proactive o reactive. Ang reactive management ay isang estilo ng pamamahala kung saan ito ay tumutugon lamang sa mga nangyayaring pagbabago sa sakahan. Gagawa lamang ng mga hakbang o taktika kapag kumpirmadong resistant o hindi na tinatablan ng herbicide ang mga damo. Ang proactive management naman ay ang pagpapatupad ng mga taktika sa pagkontrol ng damo bago maging kapansin-pansin ang pagdami ng mga damo na herbicide resistant. Isinasaalang-alang nito ang maaaring mangyari sa hinaharap at pinagpaplanuhan ito bago mangyari. Ito ang ilan sa halimbawa ng mga desisyon na kailangang isaalang-alang. Supply at uri ng binhi, mga kagamitang kakailanganin, supply ng pataba at ang gagamiting paraan sa pagkontrol ng damo. Pinaniniwala ang kritikal ang proactive na paraan ng pamamahala ng resistance para sa pangmatagalang pagpapanatili ng mga epektibong herbicides. Tulad na lang sa kaso ng glyphosate na epektibo pa rin hanggang ngayon sa GT corn. Ito ang mga pakinabang ng proactive na pamamahala ng resistance. Una, pinapanatili nito ang potensyal ng magandang ani. Pangalawa, matipid ito kumpara sa mga reactive na pamamaraan. Ikatlo, pinipigilan nito ang mga biglaan at panandaliang pagbabago sa mga nakagawiang paraan ng pagsasaka. Panghuli, pinoprotektahan nito ang pagiging epektibo ng mga herbicides para sa hinaharap. Kung mainam ang proactive na pananaw para masolusyonan ang herbicide resistance, ano-ano nga ba ang mga proactive na estratehiyang pwedeng gamitin? Sa taktikang herbicide, gumagamit ng iba't ibang uri ng herbicides na may iba-ibang mode of action o paraan ng pagpatay sa mga damo. Bukod sa paggamit ng herbicide ayon sa labeled rates, dapat ay tama rin ang timing at paraan ng pag-a-apply ng chemical na ito. Mga iba't ibang paraan ng pag-a-apply ng herbicide na may iba-ibang mode of action o MoA para pamahalaan ang herbicide resistance. Ano-ano nga ba ang mga ito? Kailangang pagsalit-saliti ng paggamit ng mga herbicide base sa iba't ibang modes of action o MoA. Ang dalas ng pagkakaroon ng mga damong resistant ay babagal kapag gumagamit ng iba't ibang mga herbicide na may iba-ibang mode of action. Pinahahaba rin nito ang pagiging epektibo ng produkto. Sa taktikang paggamit ng herbicidyo naman, ito ang mga kailangang tandaan. Ang tank mixing o paggamit ng mga premix na mga produkto na may iba't ibang mga mode of action at aktibidad sa parehong target ng mga damo ay maaaring maging epektibo. Inaantala nito ang pagsisimula ng herbicide-resistant weeds. Sa proactive na pamamahala ng herbicide resistance, importante na sundin ang GAP o Good Agricultural Practices, pati ang paggamit ng full labeled rates. Ang labeled rate ay ang rate o hanay ng mga rates na rehistrado ng Fertilizer and Pesticide Authority. Ito ang rates na epektibo sa pagkontrol ng herbicide resistance, habang underdose rate ay kulang at hindi magbibigay ng epektibong kontrol. Hindi rin ito magkakaloob ng tuloy-tuloy na kontrol sa isang malawak na hanay ng mga kondisyon. Sa huli, ang palagiang exposure sa mababang rate ng herbicide ay humahantong sa ebolusyon ng populasyon na herbicide resistant. Ilan pang mga paalala tungkol sa MoA o Mode of Action. Kailangang kilalanin at intindihin ng mga growers at extension workers kung aling mga produkto ang maaaring isalit-salit ng paggamit ayon sa mode of action. Habang ang mga kumpanya sa kabilang banda ay dapat naman magbigay ng technical brochure na tumutukoy sa MoA. Mayroon ding mode of action classification ang HRAC o ang Herbicide Resistance Action Network na maaaring pagbasehan. Sana ay marami kayong natutunan sa panonood ng video na ito. Tandaan, pag-aralan at sundin ang mga estratehiyang inyong napanood para maayos na mapamahalaan ang herbicide resistance. Maraming salamat at mabuhay ang mga magsasaka.
Yan, mabuhay ang mga magsasaka indeed. And also, sana may natutunan kayo sa video na yon. I hope the video was clear and that everyone was able to see it. I would like to take this opportunity to thank our hardworking people behind the video. Of course, the Resistance Action Committee Filipino RAC team, chaired by Ms. Florence Vasquez, and of course, Sir Audie Edralin, who will be speaking later in the session. And also to our Stewardship Committee and the Communications Committee, along with the ever-active Director Ed Luna, and to iFarm as well for putting all the efforts in producing the video for the herbicide resistance. Thank you so much, guys. And next, if you would like to see more videos like that, you can visit our CropLife Philippines website at croplife.org.ph. Again, that's www.croplife.org.ph. You can check a lot of written and video materials for references there, which you can download for free. So that's free, guys. So check out the website. You can download it for free. So next up, to give us another message, let me introduce to you the person that leads the formation of the Herbicide Resistance Action Committees within CropLife Asia. He is also the head of regulatory stewardship of biocrop science for Asia Pacific, including Africa. Everyone, let us all welcome Dr. Luis Camacho. Sir, are you there?
Okay, excellent. I will, thank you. First of all, thank you very much for organizing this event and then allow me to participate on this very good conference. So the video is really good. And then I hope you have that translated in English, because actually we'll basically support the whole region. Very good video, congratulations. So I would like to share my screen. So this year, basically the Global HRAC organization completed an update of its mode of action system, right? Then the changes include transition from alphabetical to numerical mode of action. So if you see on the right side, those are the icons that we use in our flask. And then, the herbicides we're using basically letters to classify the mode of actions, while, insecticides and fungicides are using numbers. So we are transitioning the herbicides to number as well. And then I will be some updates about that. So when the Global HRAC organization did the review, there was an addition of 4 new mode of actions. And then there was also a rationalization of the chemical family names. And there was also an addition of 14 new active ingredients. So in the next slide, basically, I would like to explain why was the mode of action classification revised. And basically, the previous revision of the Global HRAC mode of action classification occurred in 2010. So it's already 10 years since this revision happened. So this update was necessary to capture the new active ingredients commercialized since then. And then the numerical code system is more relevant and more sustainable than using the alphabetic code, which is based on English and Latin letters. And actually that system also have only 26 letters available. So today there are 25 recognized mode of actions and 4 new ones since the revision in 2010. So in addition to this, continue using English letter was not appropriate as particularly for our region. So you have China, India, and Thailand that they will not recognize this alphabet. So this is why we are transitioning to numbers. And then the other reason is that over the next 10 years, we anticipate 2 to 4 new mode of actions, which basically exceed the 25 letters from the previous code. Other important point here is that the other RACs, the Resistant Action Committee for insecticides and also fungicides, are already using numerical system, while HRAC was using letters. So this transition will allow to align all the different mode of actions on the different indications. And then other good news is that the global HRAC numerical code is totally aligned with the We Science Society of America classification system. So this is totally aligned, and the We Science Society of America system is basically mostly used in the US and other countries. And then the other thing is that the transition from this code is going to be slow. And then in the Philippines, I think that, in the Green Book, you guys already introduced the numerical code, which is very important. But in the Philippines, before that become mandatory, all the CropLife members companies were basically adding the code on voluntary basis. And then it will be a transition particularly for herbicides between letters and code. So we will not recall products. But it will be probably a moment where farmers could probably overlap letters and numbers. So we need to train them to explain why this is happening. So how was the revision of this code accomplished? So the HRAC appointed a working group that comprised technical experts in herbicide chemistry, weed biology, plant physiology, and biochemistry from the CropLife International member companies. So almost all the companies were represented in this committee. So I think that Dr. Dewey presented more or less the new list of mode of action that are right now on the current system. And then what you can see here, those two tables display the 25 current mode of action classifications as per today. So, you see on the first column, there is the HRAC and the We Science Society of America code. So this is what we will be using moving forward. The letters correspond to the legacy HRAC, and obviously in the right side, there is the mode of action classification. So we have 25 so far. So this is what Dr. Dewey showed in his slide. So basically, the mode of actions were classified in 3 different areas. So you have the light activation, you have the cellular metabolism, and then the cell divisions and growth. So HRAC made a poster, which is basically what you are looking in your slides. And this poster is available on their Herbicide Resistance Action Committee HRAC global website I will provide on the next slide. So you have additional information as brochures on the new mode of action classification. So other important update for you is that the We Science Society of America update the International Herbicide Resistant Weed Database. This is where basically all the confirmed cases of herbicide resistance are basically download globally. And this is maintained and updated constantly by the Weed Science Society of America. And then it's a very useful site to see, you know, what is the status in your countries. Any case of herbicide resistance that is reported and confirmed in a country usually appear here. So you can see, you know, all the different mode of actions that, you know, and the weed that develop resistance. So they will be on this website. So I will give the slides to the Mr. Ed DeLune, and then he can pass this information to all of you so you can have the websites in case that you want to do more research on this aspect. So the next steps regarding the new mode of action classification is basically communicate the details to the universities, researchers, the regional and country weed science societies, and the regulatory officials. And then, you know, HRAC is committed to assist those countries currently using the legacy HRAC alphabetic mode of action code, and we will support you transitioning to the numerical code. So as I say, here you have the HRAC, the global HRAC website. All the information about mode of action, posters and presentations are inside that website, and this is public. So you can download the information and help us deliver the message. And this is my last slide. So I just want to communicate that the HRAC and the Society of Chemical Industry, the SCCI, is organizing webinar series like you. And then, you know, the next webinar online will be on the 24th of September. And then we will have Dr. Hachitsu that will be talking about finding the next generation of herbicide with new mode of action. So you know, I cannot see it on my screen here, but you can see on the right side at the bottom, there is a website for registration. So, you know, this is again public. I really recommend you to register because you will be receiving the invitations to the webinar series. And then there is a lot of basic seminars about herbicide resistance. And then with that, I would like to thank you for organizing the webinar, and then, you know, congratulate for the videos and for all the efforts. I see also regulator here. I see academics, industry. Please continue with this effort. This is how, you know, the country improve, and also we maintain technologies to the service of the farmers. Thank you very much, and have a great day.
Have a great day as well, Dr. Luis Camacho, and thank you for that very informative talk, and thank you for your leadership with regard to the herbicide rock developments in Asia Pacific. And also, I'd like to reiterate that links that was given in the slides of Dr. Camacho. If you want updates on herbicide resistance, you can visit the weedscience.org. Again, that's weedscience.org. Or also, if you want information and updates on herbicide resistance, you can visit hrockglobal.com. Yeah, so thank you, Dr. Luis Camacho, for the time. So right now, I'd like to call on the next speaker. Actually, I'd like to call on to introduce us to our next speaker. Our first speaker this morning, I'd like to call on the Regulatory and Stewardship Manager of Corteva Agriscience Philippines, Ms. Bella Victoria Ermita. Hello, Beck. Mic is yours.
Thank you, Jerwin. Good morning, everyone. Before I introduce our next speaker, I would like to remind our audience that they can type their questions in the Q&A box below. So you can see it at the bottom of your screen. And we will try to answer them after our speaker has finished his presentation. You also have the opportunity to raise questions during the Q&A session by raising your hand. So I am very much excited to introduce our next speaker. He will be discussing about herbicide mode of action and resistance management. He holds a PhD in crop protection and weed science from Canton University in Vietnam and is currently the Zonal Biology Leader, Weed Management Asia Pacific of Corteva Agriscience. He has extensive research experience in weed science, particularly in commercial herbicide research and development in the Asia Pacific region, herbicide mode of action with a focus on rice and tropical upland crops, mechanism of herbicide resistance in barnyard grass and sedge species, and taxonomy of barnyard grass species in the Asia Pacific region. He has peer-reviewed 5 publications and authored 6 abstracts. Our speaker is a member of the Asia Pacific Weed Science Society and Asia HRAC. Ladies and gentlemen, please welcome Dr. Lei Yui.
Yes.
Yes. So thank you, Beck, for the introduction. So good morning, everybody. It's my honor to be here to share my experience about herbicide mode of action and herbicide resistance management. So, you know, I'm a weed scientist working at Corteva Agriscience, and you know, my company, we have a long history of research and develop herbicide for rice and many other crops. So, as Beck introduced, I have about 10 years working on herbicide resistance and development. So, and the more I work with herbicide, I would say this is my personal experience. You know, you cannot stop, you cannot eliminate, you cannot avoid herbicide resistance evolution, but you can delay it. You know, this is the best thing we can do about a herbicide resistance. Here's my photo. This photo I took in Thailand about 3 years ago, and you can see the rice field is full of barnyard grass, and no farmer want his field look like this, but it happened quite a lot in many countries in ASEAN Pacific and also the other region globally. So when you see this high of infestation, and you know that the next season and many years after, you have a lot of weed infestation. So people say 1 year of seed, you have 7 years of weed, and I think it's totally correct for many species. Okay, so my presentation, we have 3 sessions. I will introduce you about herbicide classification system, and then we go to herbicide mode of action, and we go to the herbicide resistance management. Okay, so number 1, if we want to understand about the weed and management and herbicide resistance management, we must understand the herbicide classification system. So this is the map that we got from HRAC Global, and you can see there's a map of hundreds of herbicides of today. And every few years we have a new one, but now to have a new herbicide, it takes really long time. It could be decades to have a new good herbicide. I will show you how to understand this map. Okay, so in the map you will see 3 big categories. One of this is an example. We have circular metabolism, and it means it's a mode of action. This is how the herbicide kills the plant. And we have the number here is a very important number. It's a WSSA and HRAC code. So it tells you which side of action that the herbicide will attack inside the plant cell. So here, in this example, we have the AOS synthase. This is the site of action, or the protein that the herbicide will, protein or group of protein that the herbicide will attack. And then we have chemical family. So one of the most famous one, if you are the rice farmer, you should know sulfonyl urea. And this group have a lot of herbicide, and we call it active ingredient. So one piece of this is one active ingredient. They group here because they share many similarity, especially in the site of action. So in the past, we have many herbicide classification system like HRAC, WSSA, and Australian group. So, and they're not always the same. Like for example, if we have one molecule like pinoxalam, so the HRAC code and the Australian code, they agree. But if you go to the another molecule like glyphosate, they are different. But the WSSA, they use a numerical system to classify the herbicide. And luckily, today we have the HRAC and WSSA have unified and introduced one system, numerical system. You can see here. So, it will minimize the confusion and easier for people to manage the label. And for example, if we have glufosinate in the past, it's a group H, but now it's 10. And the same for the other herbicide like cyhalofox or mesotrione. So we changed from alphabet to numerical. So that's a big improvement. Now the HRAC and WSSA system are the same. So now that the classification system. Now we go to the herbicide mode of action. It's the important one. So we need to have some key definitions before we move on. So you talk a lot about mode of action. So mode of action is the mechanism which the herbicide kill the plant. So is it how? Right? How the herbicide kill the plant is a mode of action, talking about mode of action. And then if you go to more detail, then within the mode of action, we have different site of action. So site of action is specific place in the plant. The specific place here is usually like a group of protein, or it can be inside a nucleus or a cell membranes, or anywhere inside the plant cell. So we call it a site of action. So here's where the herbicide is going to bind to attack inside the plant. And then if you go more detail, we have the binding site. So the binding site here is the enzyme or group of enzyme or the protein that where the herbicide going to bind into. So I will show you a photo of this. This is a simple illustration of a plant cell. So you imagine this is a plant cell, and we have nucleus, we have chloroplast, we have cell membranes, and different herbicide. They have different site of binding, so site of action. So, for example, if we have most of the AOS inhibitor is attack on the fatty acid synthesis inside chloroplast, or the most of auxin herbicide will attack in the nucleus. So, in different herbicide attack on the different location, and one herbicide can have one specific location to bind to, or some of herbicide can have multiple site of action. It's really complex. So you can imagine this is the protein chain, and this is AOS. This is an AOS protein. It looks very, very complex, and it produces amino acid for the plant to grow. And we have a herbicide here is 2 molecules. Popular one, we have bisfenol and propoxycarbazone. So they can bind into different locations inside the protein complex. Like it can be here or there. So depend on the binding site, it will have different effect on the plant. I mean, different herbicidal activity. For example, if binding here, maybe the activity would be higher if it's binding here. So that's this is how the herbicide trouble the plant, kill the plant. And we talk about the resistance. You know, some herbicide, some plant, some protein and enzyme they have a mutation. Here you see this is how to look in a real life. So we have protein somewhere over here, and if the plant has target site resistant mutation and you do not have the protein there anymore, so the herbicide will lose the binding efficiency. So you will the herbicide would lose the efficacy, control efficacy in that plant because it no longer perform like before. So this is a susceptible plant, this is resistant plant. There's many kind of resistance. So we have talked about mode of action. So as I mentioned, we have 3 big categories of mode of action. We have cell division and growth. That's number 1. And then we have cellular metabolism. That's group 2. And then the bigger group, light activation. So the light activation herbicide is quite popular because the plant it just totally depend on the light. The wheat we have on the field, all of the wheat they depend on the light. So many herbicide attack on the light. Actually, the light has a photosynthesis system of the plant. And in each category we have different mode of action, detail one, like some of the herbicide, the auxin herbicide, it inhibits plant growth, or we call them plant growth regulator, and some of them inhibit the seedling and growth, so we call it a root and shoot inhibitor. And for the cell, many things it can do with the cell metabolism, like the AOS, it inhibits the amino acid synthesis, or the ACCase, it's attack on the fatty acid lipids synthesis. And the light, it has a lot of things, like attack on the photosynthesis, or the cell membrane disruptor, or the pigment inhibitor, or it can attack on a phosphorylate amino acid disruptor. So you see that there's a lot of herbicide. And there's a many mode of action. And this is the list I got from our friend in Philippine CropLife. This is the register herbicide you have in Philippines. And this is a list, I think it's 41 or 42 of herbicide. And you see here different group, like group 1, group 2, group 3, 4, and it's a number. Extract and WSSI. You see it's different, a lot of group. And if you play good enough, like mixing different group together, you can have a good chance to delay the herbicide resistance. This is a shortened list. I shortened the list, and I'm going to present more detail about this molecule, like propanil, benzazone, the bisfenol, and in the 240, and the group here is different site of action, the detailed site of action, and also the mode of action category, different one. Okay, so the number 1, the popular one, the photosynthesis inhibitors. We have two types of photosynthesis inhibitor. One is mobile, the other one is non-mobile. So the mobile one, they can apply into the soil because the root can attack the herbicide and it can go up to the leaf and top of the plant. And non-mobile one usually is applied on the foliar because you cannot, if you apply into the soil, the herbicide will stay there and not going anywhere inside the plant. So it will not have any efficacy if you apply on the non-mobile one on the soil. So we have, in this group, we have, for example, in Philippines, you have two groups, like group 5 and group 7. Group 5 and 7, you have the popular, if you grow corn, you should know atrazine and promacil. If you grow like pineapple, and Duron. So the mode of action of this group is, is interfere in the photosynthesis, and it blocking the electron transport. So when it happens, the plant cell, it can no longer capture the light to produce sugar. So to human, no sugar can be a good life, but to the plant, most of the plant, no sugar is mean dead. So this group herbicide, keep the plant stop from producing sugar, so it will die. And so this group of herbicide, usually, as I mentioned, it can attack by the root or even the foliage. So, and then if we apply into the soil or even the foliage, it work as work very good. And this group, usually it have high activity on the broadleaf, and some herbicides have activity on grass, but mostly on the broadleaf. And if you see this typical injury of this group of herbicide, like the sitting, it will be the leaf will curl, and you can see some bleaching over here. And but the vein, usually it happens on the tissue, but the vein is still green, and usually the plant will turn to necrotic. So here is the soybean. If you spray this group of herbicide into soybean, you have trouble. Okay, so and then we have the second group is a non-mobile herbicide. So we have 3 examples. We have benzazone, probenil, and parawat. So parawat was banned in many countries. I'm not sure. I do not remember in Philippines today, but it's good to understand about the mode of action. So probenil and benzazone, I think you still have it in rice. It's quite old and still have efficacy on many wheat species. And you may surprise that parawat and benzazone and probenil are actually in the same family. So this herbicide, it will block, again, it will attack on the photosynthesis, and it will stop the plant from, when the photosynthesis system is broke down, the plant can no longer use the sunlight to make the sugar, and the whole plant will eventually die after, like, if depend on species, it can take like a couple days or maybe a week to the plant completely die. And the site of action is, you see here, is different depending on the herbicide. So the benzazone and its attack on the photosystem, or PS2, and the other the parawat, it attack on also photosystem, but the PS1. So PS2 and PS1, they are different, but they are same component of the photosynthesis. And if you spray, if you look at the symptom on the corn plant, you see the spot is like burning, but on the spot, because this is non-mobile herbicide. You spray in the leaf, it will most likely will stay there and not moving on the plant into the other leaf. So you see that the damage is by the spot here and there. Also here. So it's not, if it was a systemic herbicide, you spray here, it will go from here, it can go to up here, and the whole leaf will show the symptom. And again, this is no soil activity. So usually no soil activity. So if you spray on the soil, you will lose herbicide. And this kind of herbicide, because it's non-mobile. So the spray coverage is very important. If you miss the leaf, or use just half of the leaf, the efficacy will be very limited. So the good coverage when you spray is really important. And then we have the next group is the cell membrane disruptor. So in this group, we have two herbicides. For example, here we have cafentrazone and oxidazone. So they are quite popular. This one is, if you grow the bean, mung bean or groundnut, you should know this one, oxidazone. The old one, but still very popular and good activity on many wheat species. And you know, when you spray on the plant and the plant is exposed to the light, and it will form the free oxygen, you know, like peroxide. So those free from oxygen, it will destroy the plant tissue. It's not the herbicide destroy the plant tissue, but the free from oxygen produced inside the plant tissue, it will destroy the whole plant. And if you, I have some photo over here for you. Okay. So this is a bean leaf. If you spray, I think this look like oxidazone symptom. And so most of herbicide in this group is a post-emergent, and we have some have a good soil activity. Usually it do not translocate inside the plant. So again, the good coverage is important. And if you spray and then you have a really hot and humid day, and then the efficacy will go up, because this herbicide use the light and hot temperature to activate to make the herbicide have the full potential of the efficacy. So usually it have high activity on the CropLife, and some it have good activity on the grass. And you can see the symptom is like this. You can see burning here and there on the leaf, and sometimes the leaf is stacking, and eventually it will twist and it will shrink down and die. So this is a typical symptom of oxidazone. Okay, and the next group we have is a pigment inhibitor. So in the big pigment inhibitor, we have two popular ones. One is non-rice, mesotrione, and the other one is clomazone. So mesotrione is, I think it belongs to Syngenta, and it's popular for the non-rice area. And clomazone one is, I think, belong to BASF, and it has long history in rice, and it has a very it's a unique symptom. When you spray on the plant, you see the plant turn into white, very white, because the photosynthesis and chloroplast is damaged, heavily damaged. So the plant lost the green, and it will eventually die. If you see some photo, like as I mentioned, it will sometimes we call it bleaching herbicide, because it wash off all of the green color from the plant. Like, this is what happened on the plant. And here is if you spray clomazone, and if the dose is high enough, it will wash off the whole of chloroplast in the plant, and eventually the plant will die. And usually this group of herbicides have soil applied treatment, and or mesotrione you can spray on foliar. But clomazone you should spray on soil. It have the soil foliar activity, but most of the clomazone used is for pre-emergent, spray on the soil. And it have good activity on mostly CropLife and some crassi like clomazone. In Thailand, the farmer use a lot of clomazone to control the cyanophore resistant echinoclor and levaclor, and it worked pretty good. Okay, So the next one, the next group. So this is the glufosinate. Glufosinate is a non-selective herbicide and is very useful. So the mode of action of this group, is when you spray on a plant, it will stop the GS enzyme to work, and then eventually the plant, it would accumulate ammonia inside the plant chloroplast. Yeah, so if ammonia accumulation high enough, it will totally inhibit the whole plant photosynthesis, and the plant will eventually die. And this is non-selective herbicide. You can kill a lot of plant species on Earth, and at least in the cropping system. It's very effective herbicide, but it's no translocation. As I mentioned, it's non-selective, and usually has most of application on the foliar, and there are no very slight translocation, or usually in most of species is a no translocation. And when you spray, you need to make sure that you have you spray in sunny day. If it's cloudy day, then the herbicide activity will be slower, and the symptom is very easy to see in after a few days, because the plant will start wilting and dead, and you see a lot of necrosis symptom in the leaf because accumulation of ammonium. Okay, the next big group we have here is the cell in the cell metabolism. So amino acid synthesis inhibitor, we have a popular one, AOS. People talking a lot of AOS resistance everywhere. Every country I go to, they complain about AOS resistance in rice. And then they also, this is less popular. I do not hear much complaint about APSB. This is actually glyphosate, and many countries ban it. It's a good herbicide. So let's go to and see the popular group. So AOS herbicide is one of the biggest herbicide family we have today, and you can see it have a lot of active ingredient. If you remember in the map that I show you, that's a really big map, a big family, because many reasons. If many people ask me why the AOS is so many today, the answer maybe because of the cost. It's easy to develop. It have minimum barrier of patent protection, and it have a broad spectrum, high activity on many species. And usually today the Japanese R&D company, they develop a lot of AOS inhibitor today. So the AOS inhibitor is usually, it's like the name, that block the enzyme that produce the amino acid and the protein. So when it stop, the plant stop produce protein and amino acid, the whole plant will eventually die. And usually we have the popular one, Bisbee-Back, very long history in rice. And we also have benzofuran and pinoxalam. So if you spray AOS herbicide as I mentioned, it has a broad spectrum, and you can use it in rice or even non-rice. And as it's have high activity on many ways. So some AOS you can apply a pre-emergent, or many of them you can apply a post. And usually most of AOS, they are mobile inside the plant. So that's the reason why we have a lot of AOS today, and it's also the problem because AOS resistant and cross-resistant of AOS is easy. And it have symptom. If you look here, plant usually die because it could not produce amino acid anymore, and the cell cannot divide normally. Or if you spray in the rice, the plant the wheat diseases and the wheat echinocolor. The wheat eventually turns to brown, and then it will stop growing and die. It takes like 3 or 7 days to the plant completely die if you spray AOS. Some AOS have very fast action, but many of them usually take time, like 5 or 7 days. So the glyphosate was banned in many ASEAN countries. I do not remember in Philippines, but it's an interesting one. So the glyphosate, is inhibit the enzyme EPSP. It's a sixth enzyme of shikimate pathway. So when that pathway is inhibit, it would, the plant can no longer produce an aromatic amino acid, and it will die in process. This is a non-selective herbicide, and widely used in many crops globally. And if you have a corn, I know you have GMO corn, and so you should have this one. So it's it's non-selective. Most of the plant will die if you spray this on the glyphosate on it. So usually attacked by the foliar. So the symptom is low, but very high activity. The glyphosate usually is no soil activity at all. Okay, the next group of plant the cell metabolism. Okay, we have another popular group. If you grow rice, you should know Sanophop and Phenosaprop. And if you grow pineapple, you should know Halosepop and Clethodim. So we have this herbicide. They inhibit the fatty acid synthesis. So without a fatty acid, the plant eventually dies because the cell membrane, does not work normal as it should be. And one of the signature symptom of the AOS, the ACCK inhibitor. If you spray on the grass, you can really easily pull out the shoot in this button at the bottom of the shoot. So it's easy to tell if you see a herbicide spray in the field and you see this kind of symptom. So it must be an ACCK inhibitor. And this is quite active herbicide. If you spray into it, move into the phloem, when you go into the phloem, it can go up and down and translocate all over the plant. And the symptom usually take time, like 1 week, sometimes 2 weeks. And now in many countries, we have serious ACCK resistance, like in China or in Thailand or in Vietnam. There are the grass, many herbicide ACCK inhibitors could not control the grass anymore. That's not good. So now we have a seedling growth inhibitor. So the next group is seedling inhibitor, and we have two types. One is root inhibitors, and the other is shoot inhibitors. So if we talk about the seedling, the whole plant, and if you're growing rice, you should know Proteacla, Butacla, and Metacla if you have corn. So it attack in the plant cell and the growth. Usually this herbicide inhibit the cell growth and division, and it has a complex, like this group, it has complex, as I mentioned earlier the presentation. Some herbicide they have complex side of action, because maybe today we still need to learn a lot about where to attack inside the plant cell. And you look at the photo, it's, I think this corn seedling is sprayed the seedling, this group herbicide, the plant look like this. So it's same symptom you will see in the grass, like barnyard grass, will look like this. Seedling curve it cannot grow because the cell could not divide normally, and the leaf could not grow, and it eventually died. So usually this group herbicide like Proteacla, Butacla is a soil applied treatment, and it have usually it go into the xylem and it's not going into the phloem. And if you look at the herbicide is plant, I think it's a bean leaf, you can see it curl and wavy somewhere on the leaf, because this, if you see this kind of symptom, it can tell you that this plant was treated by some kind of pre-emergent and it inhibit the leaf growth. You can hear is we have a term is the bucky whipping. Plant is shocked and it cannot grow normal or cross string. Okay, this is another group, and we go to another mode of action, plant cell and growth inhibitor. So the popular one is the Edralin and FWSA group 4, and we have everybody should know 240, and many of you know triclopyr if you grow plantation, and quinclorac if you grow rice. So the mechanism of the plant growth regulator is kind of complex compared to the other group like AOS, and we also have less resistant cases report in the auxin in this herbicide because you see 240 is very old, but it's still on the market quite long because it has some reason. But today it was banned in many countries. And the site of action is multiple sites, as mentioned. So it's complex, and it's difficult for the plant to evolve a mutation to resistance. Yes, it could happen, but it took more time for the plant to resistant to this herbicide. And plant regulator, it do the job of plant regulator. If you spray on the plant will overproduce the auxin, so the plant literally it poison itself because overdose of auxin. So if you have used the plant, it will have like some microgram of auxin inside the plant cell and 1 gram of leaf, but when you spray it, the plant would produce the auxin on and on, non-stop. Then the auxin level inside the plant cell, it would go up like 1,000 times than normal, and the plant will react like something like this, and eventually it will die. And the mechanism of the plant regulator is very complex, and usually most of the plant regulator is very mobile inside the soil. And inside the plant, not the soil, because if you spray in the soil, usually it's not going anywhere. Okay, now we have another group. We have seedling root inhibitor, and here we have one of popular is pendimethalin. I'm not sure how popular it is in Philippine rice today, but in some country like India, it's quite popular. And it's not only for rice, people also can use it on the other crop like bean. So the pendimethalin is very interesting. It attacks on the microtip, and when it attack on the microtip, the plant would the plant cell division, it cannot no longer divide normally, and then in the result, the leaf and the root and the shoot cannot belong, and then it eventually dies. So let's see some photo. Easy to tell. Here you see here the root could not grow normally. It was stopped right there, and it same here. The seedling root could not grow, and if you spray on the foliar, the leaf would sometimes turn into purple, and we stuck there and will die. So pendimethalin is quite popular, and it's usually used as a soil applied treatment, and it has little or no translocation. no translocation inside the plant. Okay, so there's a symptom inhibit the plant. So pendimethalin is actually a good herbicide for many of you, but if you use it for rice, it will have some crop injury. So, but it have very broad spectrum and good activity on many wheat species. So now again, in quick summary, so why do we need to understand the mode of action? Because if we understand the mode of action, we know how it works, and we know because not one herbicide can usually control some certain species, plant species. Cannot control like just some herbicide can control hundreds or thousands of species like glyphosate, glufosinate, but most of the plant herbicide it could control a couple of species. So we need to understand the mode of action so we can select the right herbicide for the right wheat and the right crop. And we understand the mode of action. It will help you to understand the symptom of the wheat on the on the field. And of course, you cannot recommend any resistant management if you do not understand about a mode of action. You can mix the wrong herbicide and you promote the herbicide resistance, so it's not good. Okay, so the next section will be understand herbicide resistance. Many people interested in this. Okay, so quick refresh for people. So many people they confuse between herbicide tolerant and resistant. So the herbicide resistant, to make it simple, I would say echinoclor is resistant to quinclorac because I use quinclorac maybe 5 years in my field, and eventually I have a lot of resistant echinoclor in my field. So that's resistant because even after season after season after season, at the beginning the product perform extremely good, but eventually the accumulation of resistant mutation inside the field, I have the full resistant field. So it can't resistant because it have inherit. So if the mother plant resistant to a herbicide, then more likely some of the offspring would resistant to the herbicide, and resistant it can accumulate and inheritable. And the tolerant is at the beginning that herbicide have no activity on that species. For example, the Cyperette area is tolerant to quinclorac. So I would not recommend quinclorac to control Cyperette area because I know that that species is naturally tolerant to quinclorac. So you see it's different, resistant and tolerant. One needs the training, the other one doesn't need training. So we have, when talk about herbicide resistant, you will have hear about single herbicide resistant, cross resistant, and multiple resistant. So I have some example help you to understand easily. So echinoclor plus Gary were resistant to pissbeard bat. Is a single resistant, and then the same echinoclor cross Gary, but it cross resistant to pissbeard bat and pinoxalam. Even that species never treated by pinoxalam, but if it was resistant to pissbeard bat, and I spray pinoxalam and try to kill it, and it doesn't work because the cross resistant. Two molecules it have the same mode of action, and if it had resistance to one, it will have it happen to the other in the same family. So multiple resistance is a more complex thing. more complex because it can resistant to bisbee-bac, resistant ACCK, phenoxaprop, and even provenine. So those three herbicides did not belong to one family, but one plant, it can resistant to different herbicide of different mode of action. But it's extremely rare, but it's there, out there. We have the multiple resistance because it costs a lot for a plant to evolve and mutate to resistant to many different herbicides from many different families. It's rare, but it can happen. So how the wheat survive? We can have three big mechanisms of the wheat how to resistant. We have, people would talk about target site resistant and non-target site resistant, or you can say a protein mutation or metabolic resistant. In group 1, we have a lot of example like ACCK inhibitor, AOS inhibitor, photosynthesis inhibitor, and sometimes it can be overexpression of target gene. You know, as I showed you the photo figure earlier of the presentation, that the protein, the enzyme targets, enzyme, it mutate, and the herbicide could no longer bind into that target site. It's called protein mutation. On some cases, the plant could produce, you know, a lot of protein, so you do not have enough herbicide to bind into those proteins, so the plant would survive. And the non-target site is more complicated because the plant is a creature, living creature, so it has the ability to survive to the attack from the toxic agent, like if it can resist to the stress, so it has natural ability to detoxify the toxic. We have, until today, we know there's a lot of mechanism involved into the non-target site resistance, like many popular. This is the most popular one, P450. The P450 is when the plant have a lot of this, it can survive to this. And this enzyme, it can detoxify a lot of toxic inside the plant cell. So if you have a new, even you have, like, for example, you have a super wheat and have very active P4050, and you have a new herbicide that you never treat on that wheat, and you spray on the wheat, and this enzyme could detoxify and the wheat will survive. You don't want it to happen, especially when you're developing new herbicide. And for like quinclorac, it can enhance the activity of beta caseintase, so it can detoxify quinclorac, or specific for quinclorac. But this mechanism is more general for even more herbicide. Like we have APC transporter. This again is a group of enzymes help to detoxify the toxic from the environment. So in this case, help to the plant to survive from glyphosate. And glutathione as transferase is also a difficult, mechanism, because if the resistant wheat have high activity of this one, it can resist to a lot of herbicide. For example, atrazine or even paraquat. Paraquat is supposed to kill every plant, but some of the resistant species it have very high activity of this one. And multiple herbicide resistance can combine all of this in one plant, and it can resistant to many herbicides. And the other mechanism you should pay attention when you talk about herbicide resistance is reduce of the uptake and translocation. We have seen it in many species. It could resist and could glyphosate or provenil, like the plant, it no longer uptake or translocate the herbicide like it used to be. So that plant, we can say that plant already resistant to that some herbicide. Okay, so, and this is a kind of product stewardship thing, the factor to affect the speed of selection, cultural practice, frequency of herbicide use, herbicide mechanism, and I think everybody know about this stewardship, so I don't talk much about this thing. If you want to delay herbicide, you have better to remember this rule. And this is a chart I got from WSSA, and you see here we have a lot of management options, and we have the risk of resistance. But I would say I never see any country have a perfect on the green side or any. Most of the country I know it will be a mix. Like it can be they can use a lot of herbicide more than two mode of action. Like in Japan, one herbicide can have 5 active ingredients. So nothing bad about have more than 2 mode of action. But if the cropping system like full rotation, I don't think if you farmer, they grow rice, the next season they're going to grow rice, and the next 10 seasons still rice. If you ask a farmer, hey, why don't you grow corn or okra? They would say, I cannot sell it to where I can, because I cannot sell it to the local market. So, easier said than done, It's very challenging. Easier for the wheat scientist to tell farmer, you do rotation or you mix or you do cultural practice to control resistance. Easy to say, but the farmer in reality, they have many things to worry about that when they grow the crop. And because if they want to switch from rice to corn, they have to repair the land 10 hectares. Who going to pay for the land preparation? And what if they cannot sell the corn? And there's many things. So it's really complex thing in real life. So in theory, we should usually we end up with the yellow area. Most of country we have 1 or 2 mode of action. And we want to, we have hand weeding or mechanical weeding, and we spray herbicide. And some farmers, they use, they mix and they rotate the herbicide. And cropping system, no, usually we cannot do that. If you have 1 hectare or 1,000 meters square, you can easily control the weed infestation. But if you have 10 hectares or 100 hectares, it's very challenging. I cannot do hand weeding in 10 hectares, no way. So the critical factor, if you want to delay this, again, this is a stewardship thing. We can talk a little bit about this. Integrated weed management, you spray the herbicide, and then you want to make sure the survival plant will be removed. You can do it by hand or mechanical, or you can cut off the flower. You can control the seed infestation in the irrigation system. Or you can use the burn down effect, burn down herbicide before you do seeding. You can use glyphosate or whatever burn down herbicide to kill all of the plant before you do the plant or after you harvest the crop. So this is an important one. If you talk about herbicide, we want to increase the complexity of herbicide, because the plant, in 100,000 plants, there's one plant can have the mutation resistant to 1 mode of action. But if you want to have 2 plants, 1 plant resistant to 2 mode of action at the same time, the chance for it to happen very rare. It could be 1 million, and 3, it can be even more, 10 million. So you want to trouble a plant, make it, if you want to delay the resistance, you want to slow down the mutation. If you mix 2 or 3 or 4, even 4 herbicides, at the beginning, then you can the resistance will be delayed for longer. For example, if I use only one mode of action and I got resistance up to 2 years, but if I use 2 at the beginning, it could take 4 or 5, and I use 3, it could take 7 or 8 years to really see the multiple resistance or the resistance will survive in the field. So the rule here is try to trouble the weed, make it more challenging to get a mutation to survive by mixing the herbicide. Or another popular, easier solution is you spray the pre-emergent and you flood the field, and then you spray the post-emergent, and then you can see it's really difficult for the weed to have the mutation that could survive that kind of application. We can call this application program. Burn down before seeding, pre-emergent, and then post-emergent. And even you can do the hand weeding to follow up, so that would suppress the resistance at the best. One thing interesting I have seen in many countries, like in Thailand, people they went to Bangkok and they spray one herbicide, and the farmer he went to Bangkok for a couple of weeks or months, and when he just only go back to harvest a field, and his field is full of weed, and season after season he's just too tired to do manual hand weeding. And in Vietnam 10 years ago, the farmer, they care about the field, and the field scale is kind of small, like let's say 2,000 or 5,000 hectares, and he do the hand weeding every day. But now, when the young people, they don't want to work on the field anymore. They want to go to the factory, go to the city, to Ho Chi Minh City, or they go somewhere else and work and make more money, and less people to do hand weeding on the field. And the field getting bigger and bigger because the farmer can buy more land and have a consolidated pretty big land, and nobody going to do hand weeding, and then the resistance going up really fast. In the last couple of years, I could see there's huge infestation of herbicide resistant echinoclor 1 or lefoclor in Vietnam. So that thing could happen. It's very interesting. I think the same thing happened in Philippines. The young people, they don't want to do in the farm section anymore. And that can happen to everybody. And the product stewardship, again, the CropLife doing amazing job to educate people how to use the herbicide in the right way. So if you want to use herbicide, make sure that you use a full dose, because if you cut off the dose, like the label dose is 1 liter per hectare, but the farmer he use only half a liter, then the next season he's gonna have a really bad resistance. So make sure you use a full dose. Never underdose herbicide, even if you do the mixture. There's the golden rule of develop herbicide. Another thing, do we tackle the seed bank? The seed bank is the greatest weapon of the weed to trouble the herbicide, because every season it would have the new, refreshed plant ready to challenge the herbicide, and you don't want it to happen. And many seed, it could have really long dormancy, like a couple years. So you never know what you have in next season. So you want to stop them at the beginning, or if you face a field full of weed, you want to have a really complex herbicide program to suppress the seed bank in that season and the season after that. So it's really important. The farmer you can have many ways to tackle a seed bank, like use a good herbicide, cut off the flower, or prevent the seed from moving from field to field. I don't think it's practical in APAC, because in America, the farmer, they wash off the machine wheel before I go from this field to the other field. I've never seen it in APAC. In one village, it can have one machine it serve the whole village and go around. And again, this is one group cannot do or cannot have achieved the goal. It's scientists, government, pesticide industry, food production company, and user. I mean, everybody you can get to join to delay the herbicide resistance. You know, it's a very complicated job because our world today is flat and complex. So my last experience I have in the last 10 years, you know, it could take us decades to discover and develop a value new herbicide. It's easy to develop any herbicide, but the value one is extremely difficult. And today you do not see the new herbicide every year. It could take 10 years to introduce a new good herbicide, because now the resistant thing in the regulatory environment, the new herbicide must be safe to the environment and must be high activity on the weed. And you see, but the weed doesn't care about our time and money, just want to survive. So you could see the resistance after a few years or even few seasons if you use the herbicide like Maniac. So you remember that from today in the next 100 years, you do not have good herbicide every couple of years. Take a lot of time and effort to develop a new one. And the wheat eventually gain upper hand in the battle when we have less people to control them. Yeah, so that's it. This is the resource I use, and I use a lot of resource in HRAC Global and WSSA, and I recommend you go to wheatscience.com, and you should learn a lot from Dr. Ian Hipp. That's it. That's my presentation, and I hand over back to you, Beck.
Thank you, Yui. Thank you, everyone, for listening. It's time now for the Q&A, and we have one question from Mr. Pepe Laganan in the Q&A. He says, good day. Thank you for raising this very interesting topic regarding herbicide application. My question is, what is the time of application of herbicide, morning or afternoon? And then the second question is, if there is a standing plant, what kind of herbicide to be used for rice during tillering stage?
Okay, I'm trying to find that question. Okay, I have it now. So thank you, Pipi, for the question. So it depends on the herbicide. You should check on the label. Some herbicide recommend you spray on the morning because they want to have the light and the hot temperature and humid to activate and fully release herbicide power, like some herbicide like propanil and mesotrione. But if you have a herbicide like AOS inhibitor, usually you can spray on the late afternoon so you want to make sure the plant can uptake the herbicide overnight. In the next morning, it would die because some herbicide is susceptible to sunlight. The sunlight could break down the herbicide, so you will lose the efficacy if you spray that herbicide on the early morning. So check the label. I do not have. It depends on the herbicide, as I mentioned. Okay, and if a standing plant, what kind of herbicide to use during tillering stage? The herbicide during the rice tillering stage is it depends on the weed, because only the one herbicide can have activity on some weed, like cyhalophop. You can control leftophor, echinoclor, but you have no activity on the secches and the broadleaf. And 2,4-D, you can control broadleaf and secches, but you have very poor activity on the crasses. So you can check the label again, because it depends on weeds that survive in your rice field. if you want to know it, you can send me email and the photo of the wheat that survived, and I can tell you which herbicide you can use. Get back and
Okay. Thank you, Yui, and thanks to everyone who has raised their questions in the chat and those who raised their hand. Unfortunately, we still have several speakers, so we're going to answer your questions in the Q&A. And for those who raised their hand, please feel free to type your question in the Q&A. Okay, so thanks again, Yui, for that very good presentation, and I'm now handing it over to Jerwin. Thank you very much.
Thank you very much, Dr. Dewey and Beck, for that very informative presentation, and also for answering some of the questions. And right now, let's go ahead to our next speaker. Before that, I see a lot of inquiries on chats, na they're asking for the presentation file or the PDF file. So no worries, guys. We will coordinate with the speakers to give you all the copies of what have been presented. So, yeah. So for our next speaker this morning, I'd like to call on the current chair of the Resistance Action Committee of the Philippines, the Philippine RAC team. She is also the Crop Protection Development Head of Syngenta Philippines, Ms. Florence Vasquez. Ms. Flo?
Yeah. Okay, Jerwin, thank you so much. No, so good morning, everyone. So again, I would like to remind you to kindly put all your questions on the Q&A portion, and we will be very happy to answer them. Okay, so it's my pleasure to introduce the next speaker. No, I know this colleague very well because he was together with me for quite a long time, even during the diamide group, no, establishment during 2008, no, you know what we call this, to work on this resistance management. No, so he is actually a researcher currently working as R&D manager, with more than 28 years of experience in research, marketing, training, and sales. No, he conducted studies on entomology with science, plant pathology, and fertilizers. He worked on efficacy evaluation, new uses for current brands, and registrations of revolutionary crop protection insecticides. He and team set up the FMC Learning Center. He provides recommendation to FMC's Agri Decision Board and a member of the leadership team. He presented papers during local and international conferences and represented CropLife Philippines with the paper updates on DBM diamide resistance from the Philippines. Causal factors and learning during the 2011 international workshop on the management of the DBM and other crucifer insect pests in Kasatser, Thailand. Among other achievements, he also received the FB Calora for Outstanding Entomologist during the 47th anniversary and annual scientific conference of the PMCP in Naga City, Philippines in 2015. Ladies and gentlemen, let's welcome my friend Oscar Edralin. Oscar?
Thank you very much, Tita Flo. That was a very, very nice introduction, but I hope it does not really reflect on our ages. So I will, so I will just try to give my presentation. So I hope you see the presentation already in presentation mode. So this will not be a long discussion because of the very good presentation given ahead of me by two of our experts, Dr. Camacho and Dr. Ledui. So I'll just be doing it in passing and just to discuss on the mode of action labeling here in the Philippines. So why is it an important initiative for the Philippines. Resistance management and MoA in particular is very, very critical for the Philippines. The UNEP has listed pesticide resistance as the third most serious threat to global agriculture, and that is behind soil erosion and water pollution. It's an extreme case of resistance, and farmers are unable to control pests, and entire crops are at risk of being decimated or totally made unproductive. And because of this, there is an effect or impact on income and livelihood as well as food security. So when resistance starts to develop, this is where the problem begins. They will often apply products more frequently and apply more products than is recommended on the label. They end up making cocktails from a mixture of what the farmers perceive as different products, or revert to using older and more toxic chemistry if available. So on a large scale, this really has the potential to harm the environment as a whole. So resistance is a critical focus of the industry. That's why, as Tita Flo mentioned, as far back as 2008, we have been doing a lot of things together related to management of resistance development and initiated under CropLife. Resistance is more likely to occur after regular use of pesticides with the same mode of action. The more farmers use a pesticide with the same MoA, the more likely that pests will develop resistance. So sequential applications or applying mixtures of products with different effective MoA are the key strategies to delay the onset of pesticide resistance. So because of that, we really had to go into MoA labeling as an initiative. Because with this, we end up with the recommendation of rotating herbicides of different modes of action. And that is the basic reason why we recommend the frequency of changing weeds. And the basic principle is frequency of resistant weed biotypes will decline during application of alternative herbicide with different modes of action, thereby increasing product longevity. So it's not only with insecticides, not only with fungicides, but this applies to weeds as well. We don't really have to contend with the evolution of new biotypes. We'll just have to look at the weed seed bank in the soil. So with the MoA labeling initiative, resistance management is being addressed. So the main schemes for applying herbicides with different mode of action to manage herbicide resistance include the mixture application, sequentially, and application of herbicides in sequence throughout the season, and the application of different modes of action across multiple seasons. So I will not go into details related to this. So CropLife recommends the alternation or sequential application to manage resistance, as I have mentioned before. So the problem is we have been recommending this since probably more than a decade already. But it seems that the farmers have difficulty following the guidance. It's not actually the farmers only, but even with the company representatives. I've been training people for so long a time to discuss this alternation or resistance management, but they really have difficulty sending the message through from their end. CropLife and its resistance action committees have been trying to address this by advancing the understanding of the mode of action. And resistance action committees provide communication sources on MoA And the inclusion of MoA information on product labels supported by the training and other resources is really critical to ensure that growers have the information they need to follow to implement resistance management guidelines. Just to give you an idea, in short, of how we have been introducing the MoA classification. Here is just a template, but if we go back to the presentation of Dr. Leduy and Dr. Camacho, even I, as a technical person, will have difficulty remembering them. So much for our agronomists, technicians, and even the farmers. So we are really afraid that the message gets lost in translation. So you can just look at the slide. If one agronomist, let's say that person is me on the left side, I'll be talking about different modes of action, and even without expressing what's in his mind, the farmer on the right side may end up with a question that will not be expressed, but he'll just keep on nodding his head. But actually, it is not really understood. So imagine, I'll be talking about different modes of action, different active ingredients, but the farmer would actually only remember something that is easy for them to understand. So the question really is, how do I make him understand what I'm trying to convey better? So this is common for change agents or for technicians, for technical people like me. And based on experience, it's really difficult without one key thing that would allow us to give more examples and concrete examples in the field, there at the farmer's field. Okay? So, going further, MoA labeling as an initiative is now an industry commitment. What we do is to include MoA information on product labels, and which is critical to growers to manage resistance. CropLife encourages all pesticide manufacturers to include the mode of action information on the labels. And as a commitment, we hope pesticide companies will need to comply with FPA on the use of MoA labeling as a component of the product stewardship activities for the program to succeed. CropLife has a guidance document. CropLife has developed a guidance document to support this initiative. Icons are used to provide the clear and simple method to help users determine the types of pesticide and its MoA group. And the guidance also supports the implementation of effective resistance management strategies. So this is the MoA labeling guideline document on how we are supposed to put the MoA numbers on the label. So growers and extension workers need to recognize and understand which products they can rotate. Companies should provide technical brochure identifying the mode of action, and the resistance management statement should also be placed on the label. Now, looking at what we give as an example on the lower left, you see the group number, which should be for herbicides, as based on the discussion earlier, it should be a number, and one on the right side of the string is the herbicide. It's an indication. Now, for an example for premixes, you will be seeing two different strips of the herbicide modes of action. Now, what is the status of mode of action labeling for crop protection products in different countries? Following the guidelines from FPA, which was just released and included in the revised Green Book, placement of the MoA group on the label of pesticides now will be mandatory as compared to other countries. So sequential application of pesticides and different mode of action is occasionally practiced at the moment in the field. Why? Farmers are more inclined to use pesticides according to brands. One active ingredient, for example, is glyphosate, has more than 100 brands, while another favorite active ingredient, butachlor, has 30 brands. So there are actually many ingredients that belong to only one mode of action classification. So that actually makes conveying the use of alternative modes of action more difficult. So this was shown earlier, just to give you the difficulties of discussing this. If we don't come up with a system for farmers to really identify different products that can be alternated more conveniently. This is also a graph which shows you the different active ingredients that fall under specific modes of action, classified by the legacy HRAC MoA, and this is now replaced by numbers. So what's the status? Since 2012, CLP or CropLife Philippines members have been training farmers on resistance management. However, due to lack of MoA icons on the label, farmers find it difficult to practice sequential applications as recommended. So CropLife and CPAP submitted amendments in the FPA Green Book, which includes the MoA labeling, and now has been approved and released. So this is how it looks like. And aside from the MoA numbering on the label, we also add resistance management statements, which would include specific resistance management strategies for specific products. So MoA labeling, what does it really offer? Well, we find it will help provide less difficulty and hesitation on the part of technicians, agronomists, teachers, and LGU agri reps to understand the concept of weed resistance management. Because what you really don't have, you really cannot give. So this is one typical thing I notice every time I teach or I transfer information to our technicians in the field. And I'm sure it's true not only for our agronomists, but true for everyone who handles people trying to learn something difficult. Second, well, with the MoA labeling, technicians will not be at a loss when explaining to farmers how implementation of resistance management using chemicals will be implemented. So we've been in front of farmers during meetings on specific products, and in this case, herbicides. And whenever we're telling them you should alternate products belonging to different modes of action, but well, farmers will say yes, yes. But when it comes to doing it in the field, when they're already choosing the products that they have, it's really difficult, because how could they know what to alternate when even our agronomists will have difficulty giving the examples whenever asked up front by the farmers. So another thing, the MoA on the product label will allow the farmer to have an idea if products can be alternated without needing to deeply understand how the different products work. So if you will see the example on the right, sabi nila, alternate different modes of action. So how do I know which ones to use when I can't even remember the name of the technician who conducted the meeting yesterday. So that happens in the field. Some of the farmers don't even remember the birthdays of their wives. So how much more with the modes of action of different products they'll be using. The MoA on the label makes it less difficult for farmers, even their family members, to develop their own spray programs if already available on many products in the market. So what does it do? The MoA labeling, for many of us who are now discussing resistance management, it is the single critical factor which will complete the connection between the chemical industry and other stakeholders who need to understand, promote, and practice resistance management at the farm level. And this MoA labeling will make resistance management info dissemination less complicated to share. So with this, we would like to express our appreciation to FPA for the approval of the MoA labeling initiative. Thank you very much, because we've been attempting to do this past decade, but with our new director, this was made possible. So thank you very much, Director Roldan. You and your team at FPA, with the inclusion of this in the new Green Book, actually helped us do this stewardship activity less difficult. And I believe farmers will be able to respond to this more easily. So the last slide is just to thank everyone. It says here, it is not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change. So with that, I thank you very much. If you have any questions, thank you.
Okay, Odi, thank you so much for the presentation. I think we can only answer one question. This is a question, Odi, from Doc Peralta, from Gudo Peralta. Hi, Odi. In rice flooding the field, a few days after herbicide application, more than the required level of water is a normal practice by some farmers. Can this indirectly contribute to herbicide resistance? Odi, can you answer that?
Okay. One thing I would like to mention up front, Brad Godot, thanks for the question. Well, it depends on the chemistry you are talking about, because some of the herbicides will be assisted by flooding the field so that the weeds will have difficulty with it. But some other chemistries will need the weeds to be fully exposed. So if you are talking about an herbicide that will need full exposure of the weeds, flooding the field without removing the water and then spraying it is akin to spraying it underdose. So as mentioned before, if you underdose, it actually is one of the reasons why resistance development happens. So I hope that answers it. It really depends on the chemistry you're talking about. Thank you.
Okay, so since we don't have enough time, Odi, thank you so much for your for answering all the questions. Okay, so now I'll go through introduction of the next speaker. By the way, we will answer all your questions, so don't worry. So, okay, let's proceed to the next speaker. Actually, an honor for me to introduce the next speaker, also a friend of mine way back in the 1970s, very distinguished professor, academician, researcher. So he is actually a researcher, okay? He's a university researcher and a current director of the National Crop Protection Center, College of Agriculture and Food Science, UP Los Baños. He's a weed science expert, a minor in entomology and soil science. His major research is involved in weed management in rice, corn, vegetables, sugarcane, fruit, and other plantation crops. He also worked on evaluation of the risk of resistance against development in GT corn. Sorry, I mean the typing is so small. My eyes are so okay. He is the training organizer, coordination of refresher course in the identification, diagnosis, and management of pests and diseases in major crops. Dr. Magsino also received awards, recognition such as PRC Outstanding Professional of the Year Award in 2010, Distinguished Alumnus Award on Extension and Community Development in 2009, PMCP Pest Management Award in Extension and Community Development in 2010, PMCP Best Paper Award in Weed Science, and others, okay? Dr. Magsino graduated, Dr. Magsino published 12 referred journals, 28 journals and proceedings, 30 authors, and co-author training and extension materials, 5 pest management and production techno guides, and 20 newspaper citation articles. He formerly served as the head of the Technical Services Division, handling both pesticides and fertilizer registration and licensing of the Fertilizer and Pesticide Authority, and Technical Coordinator, FMC International, Southeast Asia. So, ladies and gentlemen, let's welcome Dr. Gil Magsino.
Good morning. Thank you very much, Madam Florence, and thank you very much, CropLife, for having me here. And to everyone, good morning. My presentation is about the status of herbicide resistance in rice and corn. But actually, this is the practical aspect about herbicide resistance, wherein we conducted actually the monitoring system of status of herbicide resistance in rice and corn. But before we proceed, there is a basis for this WRM or Herbicide Resistance Monitoring. This is under the Department of Agriculture Administrative Order number 8, series of 2002, or DA number 8, Importation and Commercialization of Modern Biotechnology Derived Products. And generally, the Philippines is the first country in Asia to approve the cultivation of genetically modified GM crops, foods, and feeds. And it is highly stipulated in AO number 8 that there should be no significant risk on human health and environment. Henceforth, we need to conduct risk assessment. So basically, because of the GMGT corn, or genetically modified glyphosate trait corn, glyphosate is a herbicide that deserves special attention. And we focus our monitoring with glyphosate in GM corn. And the use of glyphosate is very popular because of its broad spectrum action, high efficacy, and low cost herbicide. Therefore, the stewardship program is really important, the MoA labeling, because of the use become massive and risk from the repetitive use, the resistance to increase substantially. So it's really the right time we have this MoA labeling in herbicides. Just a brief background. So in the Philippines, GT corn was grown since 2005. As of 2013, we estimated to have 750 hectares planted to GT corn, increased to 812,000 in 2016, and decreased to 642,000 per hectare in 2017. This is the benefits given by GT corn, and according to the farmers, reduce their production costs and increase the profits compared to conventionally or ordinary corn. Again, as I've said, this requires proper stewardship and constant monitoring of the weed to prevent the evolution of glyphosate-resistant weeds in a particular field. Now, as I emphasized, we do more on the actual monitoring of glyphosate in ready corn. With our collaboration with BPI and technology developers, we started with this scheme: the monitoring, detection, and marking, the regular monitoring, field reporting, marking site. And then we have the coordination verification to conduct to report validation and conduct gene check and in the corn plants. For upload verification, the coordination between our CPC monitor, technology developers, and BPI BCT post-approval monitoring group to conduct upload monitoring and collection of PC samples proposals for bioassay. And for post-verification and remedial actions, we inform the BPI director together with experts. We scheduled meeting for the course of action as reported. To give you an example of what we have done before, this is the trial sites, courtesy of Syngenta. Of course, we have another sentinel sites from Monsanto. But in the essence of time, I would just use the data from Syngenta. So we have the Barangay Union, Kawayan City, Isabela, and Barangay Lote Baongon, Bukidnon. We have 0.5 hectares total, 1,000 meters square each for treatments 1 and 2. Before each treatments 1 to 4, we come up with treatments 1 to 2. You will show, I will show it later in the slide. This is what I mean. Originally from treatments that we use, we have 4 treatments from 2010 to 2014. These are the 4 treatments. And we came up with these treatments based on how the farmers use glyphosate in GM/GT corn. So 2 glyphosate herbicide applications at 20 DAP and 45 DAP without interrow cultivation. The same treatment with interrow cultivation, and treatment 3, 1 glyphosate application at 20 DAP with interrow cultivation, and treatment 4, the hand weedings at 20 and 45 with interrow cultivation. So from 2015 to 2019, I will show you later why we came up with this decision. From 4 treatments, we reduced it to practically 2 treatments, the treatment 1 and the treatment 2. There's not so much difference from the original treatments, but for treatment 1, this is representing the level of the playing area, and treatment 2 representing the slopy or the hilly areas. So we have 2 glyphosate herbicide applications, 80 to 20 DAP, 35 to 40 DAP with land preparation but with no interrow cultivation and healing up. And this being the practice of majority of the farmers out there in their own farm. For treatment 2, 3 glyphosate herbicide application. This is for the slopy areas, 7 days before planting, 80 to 20 and 35 to 40 for the glyphosate first, second and third application. Of course, there will be no land preparation to avoid soil erosion and no interrow cultivation and healing up. This is how we conducted, or the methods how we use during the data gathering. So we have the herbicide application 20 and 45. We use the data gathering for SDR. SDR is the sum dominance ratio, and we compute it for a specific weed species. This determines the weed density plus fresh weight plus frequency divided by 3. And with this SDR, we will see how dominant the weeds are from the first observation out to after harvest. So from the first data gathering, that is before the first glyphosate application. So we have initial benchmark information before the glyphosate application. Then for second data gathering, 15 to 20 days after the second glyphosate application. We also do the weed cover and weed control rating. The first weed cover rating before the first SDR data gathering. Second, 12 to 15 days after the first glyphosate application. And third weed cover is 1 to 2 weeks after harvest. It is very important to know the kind of, or the status of weeds. Are they survived or are they killed by the herbicides, especially 1 to 2 weeks after harvest? Are the weeds that we collected are from regrowth or from recovery from the herbicide? And we will determine that because of the SDR values per weed species. To give you an idea how diverse the weeds are in Hawaiian Isabela, very nice weeds composition. We have two kinds of sedges, the Sacrosotodus and Iria. We have three grasses, the Cynodon down to Rotbolia constituencies. And then we have 14 weeds, actually. 14 weeds. So majority are weeds in Kawayan Isabela. So Cleome, Ipomia down to Promylina odorata. Just to give you an idea that weed management is really very crucial in corn plantation, and the proper usage of herbicide should be followed. Our area in Bukidnon, here we have at least three grasses, Echinoclua, Illusion, Rotbolia. There was no stages in Bukidnon, but majority again are broadleaves. So, in the essence of time, the summary of results as of the 10-year 10 trials from the two Sentinel sites, the Syngenta and Monsanto sites, after 10 years is still, this is our conclusion. There was an evolution of weed resistance to glyphosate herbicide, no change in weed population, and no change in arthropod population. Before I will explain how this happened, let's look on the actual picture of the previous 4 treatments that we have. And this is not different from the 2 treatments, from the covering 2 treatments. You see, we have 2 runoff applications. See, very clean. After 10 years, this is how it looked like. 2 runoff applications with in-furrow cultivation. 1 runoff application with in-furrow, and of course, the hand winning. So, what is the message? So the message here is, even though we repetitively use glyphosate in our Sentinel sites, in the Syngenta Monsanto sites, but if you do it correctly, you follow the label, you follow the timing of application, the application techniques are all okay or followed. So we don't have any problem seen with herbicide resistance to glyphosate in GT corn if you steward the use of it properly. That's the upside. Now, that's the upside of our 10-year monitoring program. Now, that's why we came up with the 2 treatments, as you have seen before, because we conducted a corn farmer survey. What are the farmers really doing out there? Maybe we are doing a wrong monitoring in the Sentinel areas. We're doing, we followed all the regulations. That's why after 10 years, we haven't seen any resistant weeds to glyphosate. But the farmers are using it correctly as well as we done in the Sentinel areas. And that is a very big question. Now, from the data shared by Syngenta from our field survey, we have a total of 82 farmers interviewed in Isabela and Bukidnon, 7 barangays comprising 5 municipalities in Isabela, 6 barangays belonging to 5 municipalities in Bukidnon, representing 2 topographic locations, the plain and sloping areas. That's why we came up with this, the plain and sloping treatments, so treatment 1 and 2, as shown you a while ago. The data interview was conducted last May 2019 in Bukidnon, June 2018 in Isabela. Areas covered were the following. So these are the results of our simple survey conducted. Please bear with me. I intentionally did not include the brands of herbicide here to avoid biases and favorable advertisement as well. To be fair with everyone, these are the number of farmers that interviewed. You see, the rates liter per hectare being used on the average, the farmers in the level or plain area are using around 3 to 4 liters per hectare. Take note that 3 to 4 liters. And in the recommendation, if you're using 480 gram AI, the recommended liters per hectare is only 2, but the farmers are using 3 to 4. at least they follow the frequency of application. They're using at least two applications. For the other weed management, only 5% doing hitting up. 95% of the farmers solely use glyphosate. Solely use glyphosate. No other integrated weed management approaches. So under sloping condition, okay, at least they are using 2 to 3 in the slopy areas and spraying 2 to 3 times. And take note, of course, they are using 100% glyphosate in the slopy areas. So what do we expect then? To give you a good idea, in our on that particular location, there are top 10 dominant weed species reported before and after the herbicide application. In the level plane, okay, you see from the ranking, from the frequency of the density or presence of weeds in the area, we have 4. Okay, Ipomia on the lead with 22% frequency, Amaranthus, Comelaina, and Portulaca. The rest are listed down here. Now, weeds after herbicide application. We have 3 higher frequency of presence of weeds in the area. Number 1 in the row, Ipomia triloba, followed by Comelaina, and then Portulaca. So Amaranthus spinosus from this data had been killed or reduced because Amaranthus now have 3% frequency from 18. So take note, Ipomia on the lead after herbicide application. In the sloping area, again, on the lead is the broadleaf Ipomia triloba, followed by grassweed Rhodbolia and another broadleaf Ageratum. After application, still Ipomia is on the lead, remains after the herbicide application. Okay. Comelaina and the rest very few presence in the area. But again, Ipomia triloba in the slopy areas, Ipomia triloba magna cum laude in the level or plain areas. So we saw a consistent results from our actual monitoring in our 2 sentinel sites. So we conducted another project, the incidence of glyphosate resistant weed species in glyphosate tolerant corn production system in the Philippines. This is mostly the whole of the northern Luzon. Of course, I would like to acknowledge my partner from Syngenta who also provided the financial assistance, Madam Florence Vasquez. I will just acknowledge everybody at the end of my presentation. So these are the GPS or the areas in northern Luzon where we collected the seeds. Actually, we targeted Echinoclua colonna, Eleusine indica, Amaranthus spinosus, and Ipomia triloba to focus more or less on the weeds status with respect to resistance to glyphosate. In the essence of time, I just used our summary and recommendation based on the results of our study. So seeds collected from GD corn sites in the provinces of Isabela. In Isabela, about 55% seeds collected. In Cagayan, 27.27, Quirino province, 13.64, and Nueva Vizcaya is 4.54%. Screened through dose response study, and we found the susceptibility of, take note, Eleusine indica, Colonna, and Amaranthus spinosus were still susceptible to RR and 2RR of glyphosate 21 days after spraying. With respect to Ipomia triloba, on the first batch screening using the dose response, from Isabela area, it showed 33% to 100%. Take note, 33% to 100% survival rate from RR glyphosate. But when we doubled the rate, we got 100% mortality. But in the normal rate, we have 33 to 100% survival rate from glyphosate. Now, we further study Ipomia triloba because we are very much interested because in our sentinel areas, Ipomia triloba always appear in our monitoring. So the second batch screening of Ipomia triloba for dose response study, okay, seeds collected from the different sites. So, and we conducted the dose response spot experiment showed that only plants from the site 64 and 68 showed 30%, 33% survival rate, whereas all remaining resulted to 100% survival rate from 2RR glyphosate. So the data showed high resistance of Ipomia triloba to glyphosate spraying. Now, whether Ipomia triloba withstood 2RR glyphosate application due to morphological or genetic resistance, further verification studies are needed or recommended as a dose response study only conducted that the susceptible weeds from Eupilus banya showed 100% mortality versus from RR and 2RR glyphosate dose screening. So what I mean to say here, if really glyphosate, if really Ipomia triloba had tolerance to glyphosate, it must tolerate as well. The seeds collected from the areas have not been sprayed with glyphosate should be also tolerant. But the susceptible seeds, they've been killed by glyphosate 100% from RR and to RR. So Ipomia triloba could have a potential switch for wheat flora among sighted corn collection sites. Now, as I mentioned a while ago, we are monitoring herbicide resistance of glyphosate in GT corn. And from our 10 years of study, we found no resistance from the sentinel sites. That's why we decided to go on the actual field monitoring where the actual field is the war zone. So we have to monitor the war zone, wherein we are not really very sure if the farmers are doing the right thing, particularly the application techniques of using glyphosate in GM GT corn. So we requested, okay, so for the year 2020 onwards, we'll be doing this. We're not doing the sentinel sites monitoring, but we have a new approach. So our friends from BPI, PAMG, derived or done a new WRM monitoring scheme. I cannot disclose yet the specific new approach on weed resistance monitoring in herbicide tolerant corn. I don't know yet from our friends from BPI, particularly Dr. Joel Adorada, if this new monitoring approach that we are proposing is already approved by the Department of Agriculture and the BPI director. But then we have a new approach. Now we have a new approach on weed resistance monitoring on herbicide tolerant corn. I think this is more effective because we are monitoring the actual field conditions. And this is, of course, a industry-led activities. When we say industry-led activities, all companies selling glyphosate should be included in this new approach. So, since I cannot disclose all the specifics, but the new approach, we have three main components. The farmer survey. Now, we have a great collaborations with this one. For the farmer surveys, we have a very, very good questions for the farmers in order to detect earlier resistance, or we can prevent or delay resistance based on how they will answer the questionnaire. So this, at least for the first time, we will be having a good collaboration from BPI, FPA, the ARFO, academe, and the industry. Okay, the role of academe is really one of the pillars, as told to us by Director Roldan. Academe is one of the pillars for a successful implementation of our weed monitoring, or weed monitoring of herbicide resistance. So we have the farmer survey. We focus mainly on the farmers survey. So secondly, we have education and training portion. Education, this is more of the theoretical part, and I think we can use all the papers used by our three speakers. They have a very good presentation materials, and they are willing to share that with us. So that will help us in educating the farmers. But we are interested mostly on the training, on the actual training of the farmers. And this is very crucial. We should teach the farmers, if you selected this type of herbicide, for example, glyphosate, so the use of glyphosate is just 50% or 50% of the efficacy. Where the other 50%? The other 50% lies on the training application techniques. We have to train the farmers that they should follow the label on the right window of application, meaning they are the right growth stages wherein we could apply the herbicide. So right growth stages, right timing of the day, we need a favorable environment as well, right equipment, particularly the nozzle. You can use other nozzles, but we are recommending the flat fan nozzle and with the air pressure of 25 psi. So by educating and training the farmers on the output applications, okay, so we cannot say we can prevent, but at least we can delay glyphosate resistance in corn. So there is a voluntary reporting. This is very important that all stakeholders and plus the farmers, of course, if they see that the glyphosate cannot control most of the weeds in their particular farm, they can voluntarily report the situation. So all of us in this monitoring scheme will help and will be able to at least delay resistance of glyphosate in GT corn. With this new scheme, we really focus especially on records based on our farmer survey. Records really is a very, very important thing in our monitoring system. Records, this is the first tool in any weed management strategy. So we must keep records of what's happening in the field. So the records will provide us which weeds are problematic and which parts of the fields are not yet a problem. From the records, this will be very useful in selecting the appropriate herbicides and ensuring that there will be optimum weed control achieved after application. And records are very useful. Okay, the fourth bullet is very important, very useful where you suspect resistance weeds are starting to become a problem, as they will help to identify and address the problem earlier. So, as said by our first reporter, we must be on the proactive mode rather than reactive mode. So let us help one another in the stewardship program in monitoring this herbicide resistance. I have only one slide about herbicide resistance in rice. Okay, and I got this from the report of Dr. Al Balgazar. Accordingly, there are 2 weeds species reported to have evolved resistance in the Philippines. Spinopoeia zeylanica evolved biotype resistance to 2,4-D, and Echinococcus gali resistant to biotypes to both butachlor and propanil. From the study of C. and Mercado from 1983, Poliano et al. In 2010, and Balthasar 2017, and HIP 2019. Why do I have only one slide? Unlike in corn, we already started the monitoring in corn, but specifically more of the glyphosate, because glyphosate is packaged in the GM corn. But in rice, we have a very limited project or studies being done in the monitoring of resistance in rice. Now, I think we could seek the help or assistance again from the academe, as I've said a while ago. So we have lots of lead scientists, not only from NCPC, but we have young and energetic lead scientists from the IWEP. I would like to mention two, Dr. Heidi Ramirez and Dr. Dima Ano, and of course from Philrice. Somehow, I think they're starting monitoring of the resistance of herbicides in rice. We have many friends in Philrice and also from the ACUs in the Visayas and in Mindanao. We can tap their expertise. And aside from being a good expert, I think they are still young, they are energetic, and they are resistant. Being young, they are resistant, not to herbicide, but to COVID-19 because they're still young. So we can tap their expertise. So to conclude, in HRM or herbicide resistant management, our enemy are the intelligent weeds. Weeds will change, adapt the way they grow and reproduce to avoid all forms of weed control. Weeds have the ability to evolve over time to evade and strategies in an attempt to survive. So, hence in HRM, you need GLM. So this is not Gil Magsino, but this is good leadership management. So before I end up my presentation, of course, I would like to acknowledge the members of the monitoring group. Again, from BPI, Dr. Joel Adurada, Dr. Lilia Portales, former BPI Merdi Palakpak, former BPI Sursani Palisada, and BPI Millennial Biotech team. There are so many to mention, and the RCPC monitor team. From the WRM Syngenta, I would like to have a special mention to Doc Pepe de la Cruz Jr., Mami Buol Rodriguez, again Sir Sunny Palisada, and Dr. and Dodong Ingente from the field sites that we have in Bukidnon. And on Monsanto side, we would like to acknowledge the help of Jan Fajardo, Jermaine Castillo, and Jojo Amias. So, from the incidents of resistance to glyphosate, I already mentioned one. Thank you very much, Madam Florence Vasquez, for that opportunity. To Jojo Halukot, to Craig Roots, to Vinod, and Jen Luisa Minguez. So, with my final words, with these powerhouse collaborations from the 4 pillars, we hope and we pray that we are ahead. Take note, we are ahead, we must ahead in our resistance strategies versus the intelligent weeds. Thank you.
Yeah. Okay, Dr. Magsino, thank you so much for the presentation. No, so we just have some few questions for you to answer. I think maybe two. No, so this is actually a question from Dr. Casimiro from Madonna. So her question is, what is the economic impact of herbicide resistance in the country? Dr. Magsino?
Well, of course, the economic impact. If we control, if we are on the proactive mode, I think for the economic impact, no, that will be less herbicide uses, less cost on the herbicide costs, but if we will not be able to, if we will not be able to prevent the weed herbicide resistance, and we are on the reactive mode, of course, particularly the farmers, they will pursue on buying several herbicides, but still they are unsure if that will be effective. So for economical impact, particularly as I have mentioned in my presentation, since glyphosate is low cost, it's very effective, and in GT corn, actually it increases the profits of the farmers, not only in terms of production, but in increasing the production areas as well.
Yeah. So, Dr. Casimiro, did Dr. Magsino answer your question? I hope he answered your question. So another question is, I think this is for the glyphosate trials, no, the herbicide resistance management glyphosate trial. So what was the sizes of the weeds sprayed with glyphosate, no, Dr. Magsino?
Come again, Florence. What's the question again?
There was a question here on the sizes of the weeds. I think it was what, 80 days or yeah.
So in our recommendation, based on our sentinel areas, which is very clean, the first is 18 to 21. That's the first application upon weed emergence, and that is over the top application. And on the second application, about 42 to 45 days, that is direct application for the remaining weeds that is paid. So, but my concern is the first application. We should apply the weeds as early as possible because most of the weeds are still susceptible on earlier stages. So please follow what is recommended on the label.
Yeah. Okay, so I think there are still some unanswered questions. So we'll try to answer this and send them to you, no, later. Okay, so thank you so much, Dr. Magsino, for a very wonderful presentation. So back to you, Jerwin.
Thank you so much, Ms. Florence and Dr. Gil Magsino for that very informative topic. And Dr. Gil, thank you for sharing your studies with us. Ms. Florence, thank you for facilitating the question and answer. And we are sorry, guys, for due to the time limit, we're not going to be able to answer all the questions live. But no worries, all the questions will be answered. All right. So right now, as we move closer towards the end of the session, may I please call on the Executive Director of CropLife Philippines to give us a message of what's in store for us after this webinar, right? So, ladies and gentlemen, Director Ed De Luna. Sir?
Thank you very much, Jerwin, and good afternoon to all of us who have a very good session. I think it's more than 3 hours as against the originally planned schedule of 3 hours. But nevertheless, we have a very fruitful discussions. Interaction is quite good. We want to give credit to our speakers who took time in sharing their knowledge and expertise in this and today's webinar. Dr. Leduy, our colleague in the industry, Audie Edralin, thank you very much. Dr. Gil Magsino, thank you very much. And of course, to Luis Camacho of HRAC Asia Pacific, thank you very much also. And of course, I think there are about 238 participants who attended our webinar for today. This is actually, as mentioned by Jerwin, the second part of the series of the CropLife webinar. We've done the first one in July. It's all about insecticide resistance and MoA labeling. Today is on MoA labeling and herbicide resistance. And again, by September, we will just be looking for a comfortable date, session 3 of this webinar series on MoA labeling and resistance management. We'll tackle about fungicide. So we will send another invite again. So again, thanks to our colleagues from the industry, from the government, from the academe. We have several participants outside of the Philippines. Our colleagues from CropLife Asia, CropLife Taiwan, I think I saw their name. And of course, we would like to acknowledge the participation of the pesticide dealers. You know, their participation is very important because they are the first one who are being asked by the farmers on what products are to be used, either it is pesticide, herbicide, or fungicide. So thank you very much for registering in. And of course, our colleagues from the regulatory agency, EPA, BPI, and the rest of my colleagues in the Department of Agriculture, and of course from our state universities and colleges, whom I presume several students attended this webinar. Of course, I would like to thank before I forget, my sincerest appreciations to the team who helped us organize this webinar: Bowie, Jerwin, Audi, Joel Paredes, Beth, and Florence. Thanks for all your efforts. We have done a lot of things, and I hope if we are better today, we'll be will more or be the best in the next webinar series. Thanks to the team. And the question asked is, what do we do after this webinar? So we have listed here some course, some way forward that we should do. Of course, the ultimate user of all this information that our speakers share today are, of course, the farmers. So the challenge would be, how do the farmers understand, appreciate, and apply all this knowledge and insights that were shared today? So as a way forward, CropLife Philippines will endeavor to produce simplified training modules and information materials. Of course, we will seek the help of our friends in the government, in the academe, to help us prepare this one, which will be, of course, tailored fit for the farmers. And second, we deem it necessary that the industry, meaning the agrochemical companies, continue training the dealers, the store assistant and distributors, because as I said, they are the first person being asked and approached to by our farmers. Of course, also include our colleagues in the local government units, the agriculture technicians, and down to the farmers. It's good enough that there are agriculture students that who attended today, so we will have to reach out to more of them and maybe conduct a dedicated webinar for the agriculture students. As I picked this recommendation in the last webinar, that our dealers, pesticides dealers, should be active or should take the lead in sustaining the industry initiative. Not only as part of our initiative, our stewardship activities, but it's a matter of compliance with government regulations on mode of action labeling. So we will have to have a separate meeting with you to discuss further the details of that. And of course, well, maximize the use of social media and other means like virtual meetings at what we did today on mode of action advocacy. We are on a pandemic mode, so we have to, make use of this one as a venue and a strategy and conveying information to all stakeholders. And if need be, of course, we will try to conduct some face-to-face meeting if advisable. We'll just try to see what would be the development later on. Also, if need be, we can conduct face-to-face meeting following, of course, COVID-19 health protocols. This is number 6 is not new. We have been doing this, but we just have to continue our coordination between the industry and the government to cascade information. When I mean the government, it's not only the DA, but the LGU, of course, our expert in the academe, so that we can reach to as many farmers and other stakeholders to cascade information on mode of action labeling and resistance management. And I listed down this number 7 because I noticed that there are several attendees from the government side, in the national agency, and the local government units to study the possibility of course, mainstreaming mode of action labeling and resistance issues in the government extension curriculum on pest management. There are lots of several things that we should do after this webinar, but I think these 7 items summarizes it all. So finally, thank you again for coming, for attending. It's just the time is very limited. We were not able to respond to all your question, but nevertheless, we have your respective emails, so we will respond to it, and we will also send your the presentation. It will be uploaded in the CLP website. We can also send it through your emails, and of course, well, there is a request if CropLife will issue a certificate of attendance in this webinar. Of course, we will send you in due time your respective certificates. Thank you very much. Magandang hapon po sa inyo.
Very limited time indeed, Director Ed, and thank you so much for your initiative in conducting an online seminar on pesticide resistance, be it in insecticide, herbicide, or the upcoming fungicide resistance management topic, which is going to be the main topic of the session 3. Yes, you heard it right. This is not going to be the last time that you're going to see us at CropLife Philippines, since it has been announced that in September, we will arrange the exact date. We will be back for the 3rd and the last installment of this webinar series, the session 3 on fungicide resistance. We hope that we will be joined by the same or more numbers than we have right now. I think we picked around 240 attendees. Yeah. So hopefully more during the session 3. All right. So invite lang kayo ng invite. And as Director Edralin mentioned, for the certificates and the PDF files of the presentations, we will send it via email through the emails you used during the webinar registration. Also, additional announcement, before we leave, we would like to encourage everyone to participate in the survey questions, which will be prompted once you leave Zoom. Again, once you hit that leave button, that red leave button at the bottom of your screen, you will be notified of survey questions. Don't skip it, guys. So your survey answers will help us to do better in the next session to come. So we hope you'll do it. Also, if you want to download free video materials or training modules or reference materials, or you just want to learn more about CropLife Philippines, you may follow us on our social media channels. For Facebook at CropLife Philippines, for YouTube channel CropLife Philippines, for our website www.croplifephilippines.org.ph. So that's it. We appreciate everyone for joining us, for attending our webinar from the start until the end of the session, whether you're inside the Philippines or outside the Philippines. It means a lot to us, to all the panelists, Ma'am Veronica Tiburcio, Dr. Luis Camacho, Director Willie Roldan, Dr. Lee Duy, Sir Audie Edralin, Dr. Gil Magsino, Miss Florence, Miss Beck, to iFarm, Bo, Miss Beth, to, of course, to Director Ed Luna. Thank you guys for sharing your time, your knowledge and studies your studies in this session. We appreciate it so much. All right now, stay safe, stay healthy. God bless. Have a good lunch, guys. This has been your host. This is Jerwin Isaiza, now signing off. Bye.